welcome and good morning, everybody. My name is Dylan Tanzi. I'm the Executive Director of the SunSpec Alliance. Thank you all for joining us today for this webinar on open standards for electric vehicles and the charging infrastructure. This is continuing a theme for us where we've been highlighting and featuring open source initiatives. And this is an exciting new way for SunSpec standards to continue deployment and be adapted for new use cases. And so we are very happy to be partnering with the LF Energy and EVerest team to present this webinar today. If we go to the next slide, we have some just boilerplate. I will just be bookending this and passing this off here shortly. All right, so all SunSpec meetings are conducted in accordance with the SunSpec antitrust policy and intellectual property provisions defined in the SunSpec member agreement. This agreement can be found at the following address. SunSpec strictly prohibits market participants and their employees who take part in these activities from using their participation as a forum for engaging in practices or communications that violate antitrust laws. Confidential or proprietary information should not be discussed in open session. Please contact SunSpec management if you have any questions. So a couple housekeeping items. Yes, the deck will be distributed afterwards. We are also recording. So we do ask that you do keep yourself on mute and your camera off. We will have time for a Q&A at the end. And if you have questions during the presentation, please put it in the chat. And then we'll be able to address all your questions and comments at the end. And so I think with that, I'm going to be quite expeditious and pass it off quite quickly. I'm excited to hear about this open source initiative, and I just want to preface this by giving the call to action that this open source community is vibrant and it always needs more contributors. So please, as you're listening to the comments and the presentation, think of how you can potentially contribute and come and participate. We'll be hearing about a hackathon as well with open source development challenges that'll be happening in the next couple of months. So again, please keep in mind how you can jump in and contribute in a positive way. So thank you very much. And we will pass it off to the EVerest team.
Yeah, thank you for Dylan for the presentation. Let me skip our antitrust policy from the LF Energy community. I think we don't need that today. Maybe quickly announce the speakers. So I'm Marco Möller. I'm the chair of the technical steering committee of the EVerest project, also board member in the LF Energy project, or let's say community, and as a side job, I'm co-founder and CEO of Pionix, and we started this entire EVerest project like 6 years ago. And I have my colleague Pete with me. He is our senior architect and takes care of a lot of the technology under the hood. Later on, we will also have Rolf Riemschneider from the European Commission. He will have a big section about their engagement with open source and the energy space. And also, Erin, you will talk and introduce us to the landscape from your perspective. To get an idea what we want to cover today, standard landscapes. I want to do an introduction to EVerest. We have done a joint white paper between the EVerest project and the SunSpec Alliance, and then we'll also get more deep dive from the European Commission. And let's kick it off with Erin. Stage is yours.
All right, thank you, Marco. So I'm going to set the stage by talking about our 2 layers of grid control, the market versus the device layer. So OpenADR decides what should happen, and secure SunSpec Modbus executes what's going to happen physically. So that's from the market signal to the device action. OpenADR is our market and orchestration layer. It has one purpose. It controls real power. It can ask for more or it can curtail. So that enables the market. You can send signals as curtailment requests. A great function of OpenADR is that it's optimized for aggregation, scheduling, and grid programs. So Secure SunSpec Modbus is our device control layer. As you know, at the device level, Secure SunSpec Modbus controls communication between devices and the grid. So that's communication with inverters and DER hardware. This executes very precise and very finite electrical commands. For example, it controls real power, so it can curtail and increase like OpenADR. It also controls reactive power, so that's a VAR control, voltage regulation, so voltage variation controls, as well as the frequency watt controls. Those are the major differences between OpenADR and a Secure SunSpec Modbus layer. Notice I'm saying Secure SunSpec Modbus. So these layers operate together in practice in a way that requires Secure SunSpec Modbus. OpenADR requires encryption. Secure SunSpec Modbus covers this need. So Secure SunSpec Modbus does respond to the Cyber Resilience Act and other cybersecurity regulations in progress. And it does that by giving transparency into the device and giving control, precise control over these voltage and frequency variations. So to learn more about Secure SunSpec Modbus, I suggest you follow this QR code and download the Secure SunSpec Modbus specification. As we continue to roll out Secure SunSpec Modbus, and as the Cyber Resilience Act comes into force for all manufacturers in 2027, you can be ahead of the game by making sure that your product is compliant to the Secure SunSpec Modbus specification. Always reach out if you have questions. So in the bidirectional charging scenario, OpenADR also can't modulate voltage. And so if the grid operator needs to do this, that's where SunSpec for IEEE 2030.5 comes in. And that is our choice when you need to modulate voltage. Under the Society of Automotive Engineers SAE J3068 standard for medium and heavy duty charging, IEEE 2030.5 is specified. So that means that simple curtailment might suffice for smaller loads, but larger loads do require precise and multivariable controls. And this is really important. I have been in Europe for the last few weeks talking with manufacturers and software providers, as well as our test laboratories. And I found out recently that long-haul trucking is truly electrifying, and this will be an exciting change in the EV space. I think MAN trucking accounts for about 12% of global emissions, and they are electrifying fleets. So is Prologis. So this standard, the SAE J3068 and IEEE 2030.5, will also become important within the EV fleet charging space. I'm going to turn it back over to Marco, and he can talk about how SunSpec Modbus is going to become a part of the EVerest platform.
Thank you, Erin. So let me take it back. So what is EVerest and how has this started? One way you can look at the EV charging ecosystem is that there's a lot of issues with it. For example, I grabbed here a quote out of LinkedIn from the CEO of Monta, a backend provider, and they said like they see along different vendors that all of them have a really, really high failure rate. This famous number of 20–25% of charging session failure is so not an issue of just a single vendor, it's a failure of the entire ecosystem. So why is it so? And what will happen if you scale this industry up? So we have 2.5 billion vehicles globally. If we would electrify all of them, we would have a huge ecosystem of thousands of different types of charging stations, 1,000 of different types of cars, of backends, of connectivity clouds. We will need billions of EV chargers. And that means the issues we see right now will just amplify. So it's not getting better on its own, it's just getting worse on its own. And the issues we see is intercompatibility. So everything has to work with everything. And just in this graph, you see here billions of combinations already with that few lines. Maintenance is super hard. Getting the right spare part at the right moment in time into the field. We see stranded assets. There are so many vendors out there. Some of them go belly up after a while, and then you have $1 billion of asset worth deployed, and they don't receive any software updates. That means they render worthless within months or sometimes even days. And actually software quality is not where it should be. And we think the solution to all of that, if we get a unified open source base layer. So if all the vendors in the industry start to use the same code base underneath, it can solve quite complexity in the industry, can solve stranded assets, and end of the day also save reinventing the wheel. We see so much evolution, as Aaron just pointed out, with new standards coming to the market, with new requirements coming to the market from legislation. And instead of everyone tries to solve it on their own, we can solve this standard IT, this commodity of the technology better together. And if you just look on the standard landscape, I pointed that out already, there's always something new coming to the market. And we currently see a war on standards like, I don't know, North America and Europe doing slightly different. But even within Europe, you see, even on national level, different grid codes. You see different regulation. If you just go one click deeper, sometimes even between, not between the member states, but even within member states. And this all is slowing the adoption down. It's a waste of resources, and it creates a chaos on different implementations, which are doing things slightly different than the other ones. And that is just exploding the combinatorial complexity and testing. So we think, at the end of the day, we do all of that just to get, for example, another version of OCPP implemented. But there's no benefit in getting, let's say, 100 versions of OCPP implementations. End of the day, this is standard. Everyone could use the same. And we want to be the pool doing all of that. So we don't want to be, let's say, the next standard here. We don't want to be replacement of SunSpec. We don't want to be a replacement of OCPP. We want to be the implementation of all of that. Because if you just say you implement the next best standard, end of the day, you're just getting more to the table. And that's definitely not the mission of EVerest. So we want to be the one stack to charge them all. And we're doing that quite successfully. So we gathered a huge global ecosystem, from component and silicon vendors at the bottom to component vendors like power meters, power supplies, controllers, many charging station vendors. And actually, this list is not even complete because most of them are in the preparation mode and not yet public. We even took it a step further. We started a public forum with the operators of charging infrastructure that also they come to the table, help us to steer this ecosystem in the right direction. And beyond all of those logos, there's also governments, there's research institutes, there's nonprofit organizations. So EVerest has a really huge ecosystem. And to put that into numbers, as far as we know, EVerest is the second largest open source project globally in the clean tech space. So way beyond EV charging. Linux Foundation estimates, I think, roughly more than 1,000 open source projects out there. What is their net worth and dollar value? And we are a quarter of the entire clean tech space, what they are organized, and we are roughly half a Linux kernel. Still doubt the number myself, but I have not made them up. And also, if you look on the growth curves on how many chargers are deployed there, it's growing right rapidly. If you look on the number of collaborators who contributed code, it's 600 plus, it's more than 80 organizations. And this is, again, just the tip of the iceberg because there's stuff underneath. People can just download it. It will never show up in any of those statistics and maybe at least silently put it into their EV chargers. So what is EVerest technically? We are a firmware stack within the charger. So we are, let's say, this software running on the charger brain. There's typically running a Linux operating system for, let's say, accessing your drive and controlling your USB port. But for EV charging, you need more. You need connectivity to cars, talking all kind of dialects from all vendors, from all plug types, connecting payment terminals, human interface system, connecting standard cloud systems, for example, via OCPP, connecting local energy management system, for example, like with SunSpec, that's why we're here today, but also directly linking it sometimes into the cloud. Everest is really the software ecosystem with, I think now, way more than 1 million lines of code with a lot of modules, enabling building this charger brain, but in a way which is super extendable. So you can build everything there, from single port home AC charger to public fast charger parks with the same code base. And here I would love to hand over to Pete, who is our tech lead in the EVerest project. And please, Pete, take it from here.
Thanks, Marco, and hello also from my side. I would like to get started with a more technical visualization of the EVerest software. So Marco already mentioned it typically runs on an embedded Linux device and has a very flexible and modular architecture. So down here you can see that EVerest contains basically of a selection of modules that fulfill different purposes and different needs. It can be hardware drivers, it can be protocol implementations for protocols like OCPP for the cloud communication, or ISO 15118 for the communication to the car. There are modules that handle authorization, or also energy management, which is the topic we are focusing today. These modules communicate with each other via MQTT and are coupled via a structured types and interfaces layer. The integration is made easy because, of course, different charging stations consist of different hardware. They have different power meters, different power supplies, and different hardware parts that need to be integrated. So in order to do this, EVerest exposes stable async APIs that integrators can use to integrate their custom components. For EVerest, this is just transparent, and a power meter is abstracted using a dedicated interface, just like a DC power supply or other parts of the charging station that is integrated, and that can be done via these async APIs.
Just a quick add-on. In order to configure EVerest, I think you skipped over it.
Yeah, I can for sure quickly mention this. What you can see here is a screenshot of the EVerest admin panel that allows you to configure EVerest according to your needs. So it is possible to configure a simple AC charger with a single charging port, as well as high power DC charging stations with a more complex setup. And all of that can be done just using the flexible EVerest configuration. So you can basically design the charger according to your needs, and that makes it applicable to the many different charging stations that are out there. So we would like to call out for participation for an implementation of a SunSpec server module for EVerest. So why is that interesting, or what motivates us to do this? Marco already explained that EVerest is growing quickly and already has about 400,000 chargers in the field globally. SunSpec Modbus is the de facto standard in EMS, DER, and inverter ecosystems. And it makes a lot of sense to standardize the integration of EV charging stations with energy management systems. And that's just what the SunSpec protocol provides and what we would like to integrate in EVerest, so that it becomes very easy to integrate EVerest into such EMS and DER control systems. This is a presentation of how that would look like more from the technical perspective. So I explained the modular architecture of EVerest already. So the idea is to add another module to the EVerest module collection or the EVerest framework. The implementation would include a Modbus TCP server and the implementation of the relevant SunSpec models that we identified for or to be applicable for that use case, which is the DER AC measurement, DER capacity, DER AC controls, and also relevant for DC charging stations, the DER DC measurement model. The goal would then be to integrate that data with EVerest. So to implement the mapping between the SunSpec models and the functionality and the data that is available within EVerest. On the right side, you can see a block diagram that represents how that SunSpec server module would be integrated in EVerest, just with a collection of modules that are relevant for this. There is already an energy management module available in EVerest, and that already exposes an interface for external control. So that could be used to interface with the planned SunSpec server module. The suggested implementation approach would be to implement the Modbus TCP server in C++ and the required SunSpec models, as well as a definition of the static SunSpec register map, and then integrate this data with the EVerest data types and functionality, implement the monitoring and the data exposure, as well as the control functionality. So basically link the SunSpec implementation to the EVerest world and the EVerest ecosystem.
One clarification here is, and this is the core aspect of SunSpec Modbus, is that it is not actually a static register map. So SunSpec Modbus is designed for programmatic interoperability, and this is where we need the contributions of the open source community to incorporate this programmatic discovery, non-static register map into these open source stacks, so that we can get the broad deployment and the implementers and users of SunSpec Modbus can participate in these markets. So just wanted to interject there.
Yeah, thanks for pointing that out, Dylan. We invite contributors that are interested in this implementation of the SunSpec Modbus server as part of EVerest, that are interested in the Modbus protocol stack development, as well as EVerest module integration. It combines these both parts, and also to execute testing and validation. And one opportunity for this is the upcoming hackathon challenge during the SF Climate Week. And Arila wanted to present this and introduce this quickly.
Hello, everybody. Arila Barnes, founder of Energy IoT Open Source. We will have our second Open Energy Hackathon in Oakland, California, and you're welcome to work on this challenge as a hackathon challenge. And bonus is that we have SunSpec tools available in Oakland at informal spaces, and also a mini grid on wheels with EV charging station that's programmable for you to validate your integration. So hope to see you there, and also virtually on the Zulip communities that support this challenge. Thank you.
Thank you, Arila. And then let me tie this up. If you want to know more about the EVerest project, I think the best place to get in contact is everest.github.io. That's kind of our documentation page. From there, you find links to everything else. So if you only remember one link, go there. And yeah, we also have a Zulip chat for EVerest, and as Arila has one for the hackathon, we have the code base on github.com/EVerest. Yeah, so we would love to welcome you. And also what we from the EVerest community would contribute here is we're happy to handhold you, whoever is doing the implementation, either within the hackathon or without. So we're happy to support that. We have a special energy management working group with the EVerest project, which is actually dedicated for take care of such integrations. And I think you would also get support from the SunSpec Alliance, but we need people to bridge the gap between this. And with having said that, I would love to hand over to Rolf from the European Commission about the bigger picture of energy, of open source and the energy transition. Please, Rolf, take it from here.
Yes, thanks so much, Marco. I'm very pleased to be in the seminar and to provide you some additional information, why we need these sort of interoperability of standards. So actually, I work in a unit called Internet of Things, Intelligent Energy and Mobility, which shows already, we work on these cross-sectoral platforms, what we call it, in order to make new services available. And one key element at the moment is the smart and bidirectional charging. And we had a study 2 years ago where we see a lack of cross-sector orchestration. If it comes, between energy, between solar, between home environments, between energy infrastructures, and between mobility, passenger cars or company cars or heavy-duty vehicles. So one of the challenges, some of the challenges identified were it's the charging infrastructure, which has to be interoperable. I think that is a topic of today, but also it's a lack of data, which is shared across different data owners or those who manufacture the equipment. And a key element at the moment what we're discussing is the identification of people and devices or charge points, electric vehicles in the grid, in order to help the grid operator to do the onboarding of the different systems. So I think that's a problem statement. Meanwhile, we have first commercial services in Europe from automotive OEMs on bidirectional charging, which are mostly proprietary, so difficult to scale, but at least they show a bit of feasibility. I don't have to explain much more, talking about a complex ecosystem, meaning we need agreement from different parties, not only, on interoperability of standards, which is a good starting point, but it's also about agreement, in order to provide sort of shared services. What we see at the moment, and that's why I find the link between SunSpec and EVerest very interesting, is we see a challenge in increasing rate of installations of hybrid installations, meaning you have hybrid power plants with PV, you have hybrid charging with batteries to make energy more flexible, to store. We have storage on site, but also to balance energy in case of there's a need from the energy grid. That is because of the falling prices for storage on the one hand, and also we see more solutions coming on the market. So here again, to unleash the full potential of these new sort of private investments into the market, we need standards. And the challenge is, and I want to show you with that picture, is that in the past, when you ask for a connection point, it was always one by one. You put a charge point, you need an agreement. You put a heat pump, you need an agreement. That was the past. What we see in the future is, and then we see first member states in Europe, acting on that they look at the envelope, that you have off-grid, you have coordination of different charging and load balancing, intelligent energy management, and if you have that intelligent management able to react to grid signals, you know, you get easier and you accelerate the connection agreements, and you know, you can work with an envelope, which is what was mentioned by Aaron already, you know, an orchestration signal which comes from the grid, and making, you know, the off-grid management system to be able to work with that. And that's it's an essential feature, you know, in order to get commitment for connections. And we are working, you know, with member states in order to adopting the policy to have flexible grid connection agreements, and to increase the capacity of the existing grid, what we have at the moment, by intelligent solutions. So that's a bit of the vision. It was also mentioned by Marco, at the moment we look at open source as a strategic dimension of European sovereignty. And there's a sovereignty package coming up in April, May. And actually we look for key industrial sectors, and we look at what we call an open source stack, you know, coming from the applications down to the level of the components and the devices. You called it a unified open source layer for the charge point, you know, that would perfectly fit into the vision. We have a full stack, open source stack for modular building blocks, for connecting different systems, and for moving towards what we call software-driven systems. Because in the past, you know, most of the systems were built in hardware, and you know, they were once deployed and stayed there for the end of their life. Now the systems are more reconfigurable by software, and you know, that's why we need the flexible software-driven systems. So with that in mind, we have to look at the different interoperable standards on the APIs between the different modular building blocks. Particularly, we're looking at open source in order to also to define, to validate, and to promote the modularity, the interfaces between the different building blocks. And you mentioned OCPP, so OCPP is cloud-based. That makes the connection to the charge point. And we see, you know, that in the age of artificial intelligence and software-driven systems, the continuum between the cloud and the edge and device is getting more important. We had some research projects on that. How will it evolve? You know, what we call the cloud-edge continuum. And we see this is a slide from W3C on virtual devices, virtual objects. We see, you know, in the IoT edge software stack, we see this virtualization component coming onto a higher level of the computing infrastructure and able to do easy orchestration between different assets and systems. That's a bit of the driving force at the moment. Just to complete my presentation, we work with the SunSpec S2 standards, who has a nice illustration of that orchestration of the energy flows off-grid behind the meter. Because the standard separates a resource manager and a customer energy manager, meaning resource manager defines the interface to the hardware. So what are the choices for a customer? What is the configuration profile of a device? And how could you tune, or how could you control the device? So it's a control API or interface. And then you have the so-called customer energy manager, which is a piece of software which could reside in the cloud, which could reside on-site within the building to do the orchestration. And that is a bit of an abstraction from existing standards like EVerest, like S2, like Meta, but SunSpec as well. And other home automation standards like KNX or BACnet, you have that abstraction to abstract from the interoperability of different standards. So you move, you know, the orchestration to a higher layer and allow very flexible configuration. You might call it an app store, which could be assembled between different inputs by different developers or hardware manufacturers. On that side. So that completes a bit, you know, the orchestration scenario, our vision for the future, that for the end user at the end of the day, you know, you have a seamless landscape of orchestrating the devices, flexible to reconfigure, you know, depending on the services and the needs, the environment and the constraints also from the grid. And that makes it somehow flexible, but also very, you know, future-proof, I would say. So, in brief, the key takeaways at the moment, we see exploding energy prices in Europe, and elsewhere we see the need, you know, to move towards renewables. as a feasible source and stable source of energy, but requires much more flexibility at the consumer side, at the endpoints. So here the need for interoperable standards to manage energy flows into buildings off-grid, to integrate solar, heating, mobility, security into building operations. We look for open architectures for vibrant ecosystem. I mentioned the App Store, I mentioned the software-driven systems, which is very forward-looking and but also challenging scheme to manage a complex ecosystem, to be open, but also in terms of security is the challenges. But at the same time, it will give you the opportunity to very quickly integrate AI-based solutions in the system. The main thing is a unified software stack in order to prove modularity, in order to prove reusability of modular, eventually open source building blocks, in order to validate the open APIs and the interoperability of different standards. So the cooperation between SunSpec and EVerest is a very good step in the right direction, and we try to include the results of open source communities like EVerest into the formal standardizations, what we call multi-stakeholder platform, what we have in Europe, to include them in the formal standardization committees in order to advance also the normative standards. So for that, we need to mobilize and encourage open source communities to accelerate the standards adoption and also be prepared to apply flexible AI models for the future. So that's a bit of my vision of our part from a public authority or policymaker. Thank you so much.
Thank you so much. Thank you so much. So let me tie it up. Also, a lot of what you just said resonated really well with me, as you can imagine. I think we have already covered with an EVerest EVBus. There's initiatives to get Meta integrated. So there's really, we try to look for the EVerest project from the position of the EV charger. How can we get connectivity? How can we connect the dots? And yeah, SunSpec is really close to our heart right now. What's next? Call to action. Would love to get in touch with you within the EVerest community, within SunSpec. Just reach out to us. Use or join the EVerest project. Join SunSpec. Wolf, you mentioned before in the prep meeting, there's an OCX conference. I think it was on energy and open source, if I remember correctly. In Brussels, I think you will be there.
It's an open source conference which is organized or hosted by Eclipse, but we included on the 23rd of April a 1.5-hour session, including Linux and other projects in order to discuss the strategic role of open source in European policymaking on the one hand, and the added value for standardization to make that evident, because we have what we call a lighthouse project in the automotive domain for the software-defined vehicle, which by accident is hosted by Eclipse. But we see that a similar initiative could be possible to be launched in the energy domain, which is then hosted by the Linux Foundation. And we have RTE as sort of leading or coordinating the effort of the Linux Foundation Europe. And they're in the conference in order to have that discussion.
Perfect. Thanks a lot. And by the way, what you called, I think, software controlled or products, we call it also software-defined charging, as you also just mentioned, software-defined vehicles. That's also a theme where the EVerest community is really heavily working on. Yeah, and last but not least, we have the hackathon quickly mentioned, where there also will be particular activity around SunSpec and EVerest. Also remind again about the white paper. And now I would love to kick off the Q&A section. Thank you all the speakers, and let's see what questions do we got.
Yeah, absolutely. Great presentation. Thank you so much. I think that I hope that it's evident that this is these sorts of open source initiatives that are pulling together the various assets that can go into the whole system envelope. I hope it's evident that it's clear to our SunSpec audience, many of our members are implementers and users of the SunSpec Center, that this is another opportunity to access more markets and grow your business. And so we really hope that you will dive in And by participating, contributing to these types of open source initiatives, you're going to be directly benefiting your own market access and your own businesses. So that really, I think, is the call to action. Is this is an opportunity to get peak value from all your investments that you've already done in order to access markets like the US and Australia and India and Asia. And now we see Europe making significant strides as well in terms of deploying these standard communication interfaces. So this is another fantastic opportunity for you to grow your market access.
And just to add on this, I think open source, you don't have to be scared. You can just use it without never giving anything back to the community. That's, at least for some open source project like ours, a really valid option. There's a lot of benefit of giving something back, even selfish benefits for you. Don't want to go into details, but don't be scared. You can just try it out. You can do it silently behind your firewall. No one will ever notice. And if you want, you can also go all in. We would appreciate it.
Yeah, absolutely. So Sam, would you like to moderate the Q&A? I've seen lots of chats come in. I did want to just highlight, I completely agree with one of the things that Drew said. Standardization like this is absolutely key for scaling up the industry, which is in everybody's interest. But yeah, go ahead, Sam, if you want to pick out some good questions for us.
So we've got a question here from Mosen. What acts as the authoritative system model across EVs, DERs, grid operations, and markets? And how is consistency maintained across all these systems?
Yeah. And it absolutely is that different countries, there's different authorities, and that's one of the benefits of standardization. Is ideally you're able to enter as many markets as possible with the same products and SKUs, etc. But absolutely, it's one of the challenges of is navigating what jurisdiction is requiring what. But go ahead, Marco.
No, I just was also about to say, like, this is your domain. Please go ahead. But just my 2 cents. I think different markets will work differently. The only thing what we as Everest community try to prepare is that software-wise, you're prepared as best as possible. So ideally, different markets are just for you different configuration flags, but no new code. That's our philosophy here.
Agreed.
Great, thanks. So we've got a lot of comments here. We'll get down to one more question that we have. May have already been covered, but want to circle back on it. How does Everest relate to Citrine OS?
I can take that. Citrine OS is basically just charge point management system server implementation. So Everest focuses on the firmware of the charger. Citrine OS focuses on the orchestration system for many chargers, regarding payment, regarding, I don't know, authorization of charging sessions. So it's complementary. And Citrine OS and Everest speak the OCPP protocol to each other. So in a way, we are siblings. We are part of the same open source ecosystem. We try to solve different parts of what's there.
Great, thanks. And we have a lot of comments here as well. I think those were just the main 2 questions. But if anyone has an additional question that they'd like to come off mute and ask, or any comments they'd like to make to the presenters to engage in some conversation, feel free to do so.
Well, I'll go if no one else is going. Sorry.
No worries. Go ahead.
So just hi everyone. Thank you for this presentation. This is really helpful. So Dylan and I have chatted in the past. We're kind of a newer nonprofit, really working to help kind of solve, ideally try and address some of the confusion and ambiguity around all that, as you mentioned, the variety of standards that exist in the market today, and especially with North America, just trying to help kind of bridge the gap of like what standards are really the most central ones we should try and encourage industry to focus on and educate end users on those. So I am curious, and one of our main audiences is working with utilities that have to navigate these standards and provide direction to their customers when it comes to incentive programming. So I would love to get, I guess, the presenter's perspective on how do you, like, what's a good message to utilities and thinking about incorporating, I think, the best practice around EVerest, and it sounds like the integration with or the relationship with SunSpec. What do you see that looking like? Like, what is that kind of message we can give to utilities and help them understand this?
Yeah, I'll comment first, and then I'll invite everybody else to chime in here. But yeah, so one nice thing we've seen is with SunSpec being encoded into multiple national and international standards is that virtually every single device that's connected to the grid does have a standard communication interface with SunSpec Modbus, or they have demonstrated compatibility and interoperability with 23.5 interfaces. So this is by law in North America and Australia, India, multiple Asian countries, and because the manufacturing base is global, that you can find the standard SunSpec Modbus interface on every PV and stationary storage system that's in the market. And then you have layered onto that these sorts of open source initiatives where you can start to incorporate the rest of the envelope and that's the direction I think that that the industry is going here in North America. So on the SunSpec side, you have a common baseline standard communication interface, and now we're finding other opportunities, additional opportunities to incorporate the whole system, the whole home, whole building, electric vehicles, and so on, and load everything.
Yeah. I will echo that SunSpec is a great start, and especially coupled with the 2030.5 protocol, which utilities really like, and it's very compatible with their DERM systems. PG&E, for example, works with Schneider Electric exactly on the 2030.5 protocol. So that's the utility side. From community perspective, like I mentioned, we started with SunSpec as an open energy hackathon because it has this ecosystem of OEMs. And just to give you a perspective, in 2 days, we were able to stand up a SunSpec gateway that can connect to a proprietary Modbus and expose the standard SunSpec. So you can talk to that SunSpec-enabled proprietary inverter and be able to standardize your higher-end products like Citrino-S or Flex Measures or any other energy management system of your choice on the SunSpec standard. So if inverter A fails, you can replace it with inverter B as long as it speaks the SunSpec. And that's very valuable to communities and nonprofits because it can stretch their dollar in the face of economics.
Let me also quickly add slightly something. So from the EVerest community, we now started an initiative for charge point operators, and I know many utilities also operate their own fleet of EV chargers around the world. At least many of the big operators are also utilities as a second business. And we launched this initiative around EVerest to bring all the operators together in the EVerest CPO forum. I would love to invite those CPOs there. End of the day, we can help you to get better products from different vendors. We can help you to get more long-lasting assets, less risk of stranded assets, less integration cost, because only speaking a standard, unfortunately, doesn't mean that everyone speaks it exactly the same way. Not sure how bad is it with SunSpec, but with things like OCVP or ISO 15008, we see huge issues. And having a common library is actually resolving that there quite quickly. and they would love to invite you there. And then second remark, as I'm part of the LF Energy, we have a lot of big open source projects pointing towards other angles of the being a utility business, from grid control to simulating and emulating entire grid procedures. So also please have a look at the bigger LF Energy portfolio. Maybe there's something in for every utility.
Yeah,
And
thanks.
you is welcome to join. Southern Edison is already member of Linux Foundation Energy from the United States.
Yeah, there's many utilities already.
I might come in, to look a bit from the European side, because we're running what we call a Digital for Energy Expert Group, which covers both energy people as well as mobility, automotive, and the whole value chain and charge point operators. If you talk about from the mobility perspective, at least in Europe, with increasing share of renewables, heat pumps or EV charging, you have a much more decentralization and a much more volatile energy system, at the grid edge. And we already observe in certain areas in Europe capacity limits in certain countries. And there was a study from the IEEE saying that with an intelligent management of energy flows behind the meter and coordinate with the grid, you can increase the capacity by 60%, 60 without digging in the ground, without hardware investments. So that is a major opportunity. And the question is, how do you make it happen? And in the first place, they talk about the energy market. You can contract flexibility on the wholesale market, where you need flexibility service providers, which is sort of an official role, to participate in the energy market. It's quite complicated. So we discover at the moment, there is different roles, and apart from that role, there's a more technical role, what they call technical aggregator. Aggregating, as I showed you the picture, resources behind the meter, also resources in a certain area, in order to respond to flexibility signals. And then, if the energy provider is able, if there's an emergency or there's an urgent need to send flexibility signals, and on the other side, there is a system that's able to respond to the flexibility needs in order to respect maximum voltage or voltage fluctuations or capacity limits, or to increase consumption if you have an overcharge of solar energy. You get an equilibrium between demand and response. So that is a bit of the mechanisms it works at the moment. As I said, we're missing the standards. I think there you do some good work. We're missing experience on the business model. As I said, there are first bidirectional charging solutions in Europe, and they start with a sort of a lump sum. You gain €700 per year if you connect the vehicle during peak hours or during the night. And it's a first trial, to what extent an energy operator can associate price tag to flexibility. Because so far, the business model is not linked to flexibility prices. And on the other hand, to what extent the flexible energy, the reserve capacity of electric vehicles could be unlocked and could be then provided as a flexibility resource to the energy grid operator. So we are in a very early stage, but first steps on how to gain experience and how to see how it works, we're starting working on that. And we work on the interoperability between, as said, hybrid batteries, solar, and charging points on the one hand, but also, interoperability between transmission and distribution operators, and about, on the basis of sending flexibility signals, between the grid and the off-grid management systems.
And in fact, one of the projects we did at SunSpec in the early days, I think it was an EPRI project, we demonstrated the viability of going to 100% penetration if you have a standardized communication interface, so you can dispatch all the assets on the grid. So demonstrating the opportunity here if people invest and do things well. I see Thomas, I think I see your hand up if you wanted to come off mute and ask a question or give a comment.
Can you confirm that you hear me?
Can hear you.
Yes.
and I think you partially addressed this, but you know, in context of charging, right? You have OCPP, you know, and OCPP 2.1 is gaining 1547 compatible or approval or aligned with 1547, and they're continuing to work forward to that. But when you start looking at the chargers, though, you know, how do you deconflict the various commands that may happen over these different protocols, right? You know, in 1741 SC CRD, you may have a 2030.5 channel. You know, from the aggregator perspective, you have SunSpec here, right? And then from the charging network provider, you have OCPP, you know, and they can issue similar commands. But, you know, at the end of the day, you probably want one signal over the other. How, you know, as an implementer of all this, how do you deconflict those different objectives, for lack of a better word?
Pete, is that on you? Oh, sorry.
Well, I think it's related to the first question, actually, that it's down to regulation and how you basically design your charger and what kind of control you want to make available for the different kind of sources that exist. As Marco pointed out, from the EVerest perspective, we try to be able to be ready for these different kind of signals and implement them downstream, which basically means send these signals to the car or control the power or implement these kind of commands. I am also missing a little bit just that one additional point, that there are like protocols that try to define what kind of priorities certain signals have. And I think that could be also a good solution to this problem, to basically order these kind of different signals that exist.
Yeah, I would add on that, yes, it's going to be, at the end of the day, up to the national regulation, the utilities policy, etc. However, you as a market participant are not powerless. There are industry alliances like SunSpec, where if the industry consolidates around a preferred method, and it has on the generation side with SunSpec Modbus and 23.5, that you are able to impact what policy and regulators decide. So come join the alliance, and you can influence us, you can influence the regulations and policymakers as well, by demonstrating industry consensus. They don't actually want to reinvent the wheel every time they write a new grid code. They do look for signals from the market participants. So you have to participate to let them know what's required. You can tell them. It would be my message.
Maybe just to add on this, I mean, from the EVerest perspective, we try to be ready for whatever regulation or standards came up with. So we try to have a system which is just configurable to behave one or another way. So you, as Rolf pointed out, everything is software defined and not hardware defined. And second, we also interact with a lot of those standards as being a playground. So with OCPP, with ISO 15118, with megawatt charging, with many of those standards, we are sometimes so early on with implementing that sometimes we come into ambiguities, and then we circle back to the standard people like, so what should we do? And then they think, okay, well, sometimes they ask us, okay, oh, we discovered ambiguity. What has EVerest done? And then we are influencing each other by sometimes just whatever we randomly choose became the standard, or sometimes we became the playground for new ideas in the standard. So yeah, this is a big joint challenge across all people here in the room.
Yeah.
But essentially, I think you touched upon a critical path. What we see in the policy making at the moment is a bit of a dual way of approach. One way, you know, what they call implicit energy management and implicit flexibility, leaving it to the technical aggregator to do the brokerage. And the other one is, which is implemented in some of the laws when recently launched, is an explicit flexibility. That if there's really an emergency in the grid system, you know that they have the authority, you know, to shut down charging or shut down any energy consumption on the consumer side. And so that is a bit the way, you know, you enforce flexibility on the one hand, it's explicit, or you keep it to the market, and we wait for the role of an aggregator who uses then the technical standards, what we have from ISO 1511 or from IEEE 2030 or from EVerest or SunSpec, you know, in order to combine the signals and do brokerage.
Okay. Thank you.
Thank you, Thomas. Well, we are at time. We're 2 minutes past, so I really appreciate everybody who's hung on with us. If the other panelists want to stick around for another minute or two and answer another question, we can do that. I don't know if anybody has a hard stop or not. Yeah, I think this has been a really, really fantastic webinar. The EVerest program is a great, just a fantastic additional signal that there's more market opportunity out there. And everybody has their hand on the steering wheel, the ability to come in and influence and participate and make this as valuable and useful as possible. So that's where SunSpec and EVerest, I think, come in together and make a great tableau. So,
hey Dylan, I got a quick question for you.
Yeah, go ahead, Andy.
Yeah. Would SunSpec, because you have such a nice position in the regulatory market with IEEE 1547, would you guys consider contributing a Modbus server to EVerest for those models, for 700 models? Or is that ever on the plate, you know, on the table?
Yeah, I mean, so we have the SunSpec PySunSpec library on GitHub. The source code is all out there, and we are contributing by doing this type of webinar and to encourage the community to come in and participate. SunSpec is a nonprofit trade alliance, so we don't have a staff of programmers to actively do code development. But what we have is this community, and so we hope that you guys will come and contribute.
Gotcha. Thanks.
Hey, Dylan, this is Tom, and yeah, send people to dursec.io. give us a buzz, and we have simulators as well.
Mm-hmm.
Happy to participate with you.
Yeah, and one of the benefits of SunSpec membership is the SunSpec dashboard software, which includes simulated devices and so on. And again, the source code is available on GitHub. So there's lots of code available and tools. And
yeah, and you can try the dashboard with equipment, like I said, at the Open Energy Hackathon or join spaces. Yeah.
Yep. Okay, well, we've gone 5 minutes over. This has been really, really good. I really appreciate Marco, Rolf, great presentation. Thank you to the audience as well for hanging out here, and great questions, great engagement. So join the EVerest open source program, join the SunSpec Alliance, DER, and generation companies. Make sure you get certified so you can sure you have full interoperability and you can play in these types of environments with EVerest, and access more markets and do more business. And also come to Arilla, visit Arilla, contact her as well for this hackathon program, where you can have a great opportunity to participate and contribute to these sorts of open source initiatives. So thank you all so much for your time.
Thank you.
Thank you.
Thanks.
Thanks everyone.
Bye-bye.
Bye-bye.
Bye, everyone.
Bye.